Yeah, so I know it's very late. Good afternoon, students. There's nobody online. Yeah, Tanishka, good afternoon. Good afternoon, Tanishka.
Good afternoon.
Tanishka, I've shared the screen. Is it visible, Tanishka?
Yes, ma'am.
All right. I'll give you 3 minutes, class, to answer this question, to answer these questions. Good afternoon, Netra.
Good afternoon, ma'am.
Yeah. Take down the questions and answer them. We shall discuss the answers. Yeah, done, children? Arjun, done? Okay. Netra and Tanishka?
Yes, ma'am.
All right. All right. So what are rational numbers? Rational numbers have a P by Q form. Irrational numbers do not have a P by Q form. Correct? Rational numbers are fractions. And these fractions on division, when you divide the numerator by the denominator, the remainder can be 0 or not 0. These are the two cases. Okay, so rational numbers are numbers that have the P by Q form. So P by Q meaning division is possible. You have a numerator, you have a denominator, so you can do the long division, the regular long division. When you divide, two cases arises. Two things can happen when you divide. Either the division comes to an end with a 0 remainder. You divide and the division comes to an end with a 0 remainder. Or the division does not come to an end at all. You keep getting remainders. And you'll also see that the remainders are repeating. Only these two cases are possible, which means a rational number or a number that has a P by Q form will have a terminating decimal expansion when the remainder is 0, and we'll have a non-terminating repeating decimal expansion when the remainder is not 0. These are the only two cases possible. Either the remainder is 0. When you have a P by Q form, either the remainder is 0 on division or it is not 0. The division keeps going on and on. So when the remainder is 0, the quotient is a terminating decimal. And when the remainder is not 0, in which case the remainders will keep repeating. In that case, the quotient will be a non-terminating because the division has not come to an end, will not end. So it will be a non-terminating decimal, but repeating decimal. It's non-terminating because the division did not end. If the division does not end, how will the decimal terminate? It will be a non-term. The decimal can terminate only if the division comes to an end with a 0 remainder. So if the division does not come to an end, the quotient will be a non-terminating but repeating decimal. And what is an irrational number? It does not have a P by Q form, and the decimal numbers are non-terminating, non-repeating, or non-terminating, non-recurring. So you have to use the definition. You have to use a definition to classify numbers as rational or irrational. You'll have to use a definition. So rational will have a P by Q form, or a rational will be a terminating decimal, or a rational will have a non-terminating repeating decimal. So all these three are rationals. If you look at a P by Q form, it's a rational number. If you see a terminating decimal, it is a rational number. And if you see a non-terminating but a repeating decimal, that also is a rational number. So P by Q is a rational number. Terminating decimals are rational numbers. Non-terminating repeating decimals are also rational numbers. Then what about irrational? Non-terminating, non-repeating. So only one thing. If you see a non-terminating, non-repeating decimal, it's irrational. It doesn't have a P by Q form. Irrationals do not have a P by Q form. So you should use these definitions to classify these numbers as rational or irrational. You'll have to use these definitions. So now look at the first one. Check your answers. I'm not asking any of you. Check your answers. So the first one, you can see that the decimal comes to an end. 3232, whatever, 323, whatever I've written, but it comes to an end. It's a terminating decimal. The decimal part may be lengthy. Maybe the decimal part has 100 digits. That's okay, but it comes to an end. It comes to an end. So it's a terminating decimal. This one is a terminating decimal, and hence it's a rational number. You don't have to write terminating. I'm just telling you for your understanding. The first one is a terminating decimal, so it is a rational number. It is a rational number. Why is it terminating? Because it ends here. 2, finished. The decimal part can have even 100 digits or 1000 digits, but it comes to an end there, right? It's a terminating decimal, so it's a rational number. The next one, you can see it's non-terminating because there's a bar there. There's a bar. That means what is it? 0.090909 goes on forever. Non-terminating. but it's repeating. See what is repeating? 09, 09, 09, repeating. It's non-terminating because it goes on forever. 09 goes on forever. It's repeating because 09 repeats. So what kind of decimal it is? It is a non-terminating. Non-terminating because it doesn't come to an end. Repeating decimal. So it is a rational number. So it is a rational number. Yes or no, children? What about the next one?
Non-terminating, non-repeating.
Non-terminating, non-repeating. Correct? Non-terminating, non-repeating. So it's irrational. Watch it out, Danya. Okay. It's irrational because it's non-terminating, non-repeating. The fourth one, is it terminating or non-terminating? Non-terminating. Is it repeating or not repeating? Repeating. It's non-terminating, repeating. Then it is rational. Then it is rational. The fifth one, you should find the value. Wherever possible, you should find the value. Can you simplify the fifth root of 32? 2. The fifth root of 32 is 2. What have you written, Danya? You've written irrational? Yeah. Okay, so what is the fifth root of 32? You should simplify if possible. What is the fifth root of 32? See here. How do you write? 2 into 2 into 2 into 2 into 2 is 32. You can do this method, 32 and then 2 16 times, 2 8 times, 2 4s are, 2 2s are, and 2 1s are. All right, so you get 5 2s. The product of 5 2s is 32. So from when the numbers are under the fifth root, from 5 5s, 1 5 comes out. From 5 5s, 1 5 comes out because the numbers are under the fifth root. From 5 equal factors, 1 comes out. So the value of the fifth root of 32 is 5, and 5 is 5 by 1. 5 by 1 is p by q, and hence it is rational. Pi. What about pi? Irrational, because because the value of pi, is a non-terminating, non-repeating decimal. Because the value of pi, see, for calculation purpose, we take pi as 22 by 7, but pi is not equal to 22 by 7. If you take a non-terminating, non-repeating decimal, now pi r square, you have to find the area of a circle, pi r square. If you take the non-terminating, non-repeating decimal, how will you calculate? So for working purpose, we take it as 22 by 7, but it is not equal to 22 by 7, exactly equal to 22 by 7, because it's a non-terminating, non-repeating decimal. It does not have a p by q form at all. The value of pi is a non-terminating, non-repeating decimal. It does not have a p by q form at all. But for the sake of calculating, we take it as 22 by 7 or 3.14. We take this, slide the door, slide the door. No, this one, slide it. Yeah. Okay, so pi is a non-terminating, non-repeating decimal. It does not have a p by q form, but we take it as 22 by 7 for the sake of calculating. So pi is a irrational number. Pi is irrational because it is a non-terminating, non-repeating decimal. Then 22 by 7, p by q. 22 by 7 is p by q, integer by integer. It's a rational number. This is a rational number. Yes or no, children? 22 by 7 is a rational number. Yeah, what about this 8 one? Rational, because you can simplify it. What is the cube root of 729? 27. Oh, no, not 27. Sorry. Square root is 27. The cube root is 9. 9. Okay, for the 8th one, the cube root of 729 is 9. And what about the 4th root of 625? Huh? 5. So 9 by 5. Wherever you can simplify, you should simplify and then comment. So the cube root of 729 is 9. 4th root of 625 is 5. 9 by 5 is p by q. And it's a rational. Any questions, Tanishka, Netra?
No, ma'am. It's clear, ma'am.
Yeah. Yes, Madhumita? No, it doesn't work in my laptop. That's the problem. All right. Over to the next one. Yeah. So given the value of 1 by 13, you'll have to find the values of or the decimal expansions of 4 by 13 and 12 by 13.
Completed, ma'am.
Yeah, we'll see the answer. So 1 by 13 is given to be 0.076923 recurring. So 4 by 13 can be written as 4 into 1 by 13, which is 4 into the value of 1 by 13 is 0.076923 recurring. So you just have to multiply. See, 4 by 13 is 4 into 1 by 13. And it's 4 into the value of 1 by 13 is given to us in the question. So now multiply the regular multiplication. If you want to understand that, please look at the board. So 4 3s are 12, 2, 1 carry over. The usual multiplication, 4 2s are 8 plus 1, 9. 4 9s are 36 plus, 36, 3 carried over. 4 6 are 24 plus 3, 27, 2 carried over. 4 7 are 28 plus 2, 30, 0, 3 carried over. 4 0s are 0 plus 3 is 3. 0.0 into 4 is 0. And there is a bar on 6 digits. So these 6 digits, there will be a bar on these 6 digits. All right, just check if my multiplication is correct. The regular multiplication. How do you otherwise multiply? If there was no bar, how will you multiply? Do the same multiplication. Similarly, 12 by 13. 12 by 13 will be 12 into 1 by 13. 12 into 1 by 13. So 12 into the value of 1 by 13 is 0.076923 recurring. Kindly tell me the product.
0.923076.
3076. Okay, here also students got the same answer. Very good. Finished, boys? Done? Arjun? Okay. Next one. Insert one rational. Insert one rational and one irrational. One irrational number between 1 by 6 and 2 by 7. Insert one rational and one irrational number between 1 by 6 and 2 by 7. Yes, children. How do you insert a rational number? What's the method? LCM. You bring the fractions to the same denominator. Okay. Bring the two fractions to the same denominator. So 1 by 6. All right, children. So you can see now we have 7 by 42 and 12 by 42. So what is it? Tell me one rational number between these two. 8 by 42. And that can be simplified also. Or you can like 11 by 42. You don't have to simplify. 11 by 42. You don't have to spend time simplifying. You can write 8 by 42. You will have to again simplify. Right? 11 by 42. You don't have to simplify also. So just one they are asking. Now between this you can write so many. You can write 7.1 by 42, 7.2 by 42, 7.3 by 42, 7.01 by 42, 7.001 by 42. There are so many rational numbers between these two. Between 7 by 42 and 12 by 42, it's not that we only have 8, 9, 10, 11 by 42. No, there are so many. There are infinitely many rationals between two rationals. And what are they now? For example, so see here, you can write 7.01 by 42. Does 7.01 lie between 7 and 12? 7.01 lies between 7 and 12, right? So you can write 7.01 by 42. What is that? It is 701 by 4200. Shift the decimal point. Shift the two decimal points in the numerator. That is, you multiplying the numerator and denominator by 100 in order to move the decimal point. In order to move the decimal point, you're multiplying the numerator and denominator by 100. So you get 701 by 4,200. So like this, you can write 7.001, 0001 by 42. So like this, can you now imagine there are so many numbers. Yeah. Now one irrational children. One. Yeah. 4 point. How did you get that? You divided 42 by 9. Why by 9? See, if you write 8.5 by 42, 8.5 by 42, 7 and between 7 and 12, you have 8.5. So 8.5 by 42. When you move the decimal point, 85 by 420. I'm saying this is a rational number, not irrational. This is a rational number. So to find one irrational between 1 by 6 and 2 by 7, 1 by 6 and 2 by 7, you will have to find the decimal expansions of 1 by 6 and 2 by 7. You will have to find the decimal expansions of 1 by 6 and 2 by 7. So what is it? 0 point. So you can add a 0 here. 6 ones are 6, correct? 4 is a remainder, add a 0. 6 6 are 36. 4 is a remainder, add a 0. 6 6 are 36. Goes on like that. So 1 by 6 is equal to 0.16 recurring. 6 recurring, only 6 repeats. And when you divide 2 by 7, 2 times 14, 6 remains, add a 0. 8s are 56, 4 remains, add a 0. 5s are 35, 5 remains, 7s are 49, 1s are 7, 3, 4s are, you don't have to do so much, but 28 and goes on. It goes on like this. You can, your 2 is a remainder if you want to continue. 2 is a remainder, add 0. Then again it will be 2s are 14. 2s are 14, correct? So it is 0. What is 2 by 7? 2 by 7 is 0.285714 recurring. 1 by 6 is 0.16 recurring. And 2 by 7 is 0.285714 recurring. Now you will have to insert one irrational number between these two. So irrational means what? Non-terminating, non-repeating. Irrational means non-terminating, non-repeating it should be. That's all. It should not have a P by Q form. You should not write a P by Q. You should write a non-terminating, non-repeating decimal between this, in this range. So this is 0.1, that is 0.2. This is 0.16. So you can start with 0.17 and write anything. This is the minimum one end is 0.16. The other end is 0.28. So you can write 0.17 and anything, or 0.18 and anything, 0.19 anything, 0.25 and anything, because this is like 16 and 28, no, between 16 and 28. 0.16, 0.28. So you just have to start with 0.17 or 18, 19. So like say I wish to start with 0.21 because I know I'm safe between, it is between 16 and 28. Okay, so 21 is safe. Now write anything you please. You can write nines also. You can write 9, 9, 9. Then you change your mind. So 8. Then you change your mind. You change your mind again. You change your mind. You change your mind. You keep changing your mind. But don't forget to put the dots. It goes on like this. It goes on like this. Or you can write 0. Like 1919, 1999. Like this, it goes on. So we have written 2 here. The 2 irrational numbers between 1 by 6 and 2 by 7 is what you see on the screen. Netra and Tanishka?
Yes,
Any
ma'am.
questions?
No, ma'am.
All right. In the fourth one is option A, a rational number or an irrational number. Half of 5 plus 6. Is it rational or irrational? Forget if it lies between 5 and 6. Don't see. You cannot check both at the same time. One is it should be irrational. The other is it should lie between 5 and 6. One condition it should lie between 5 and 6. The other condition it should be irrational. Don't check both first. Is half of 5 plus 6 rational or irrational? Rational. So leave it. Even if it lies between 5 and 6, how does it matter? It is rational. Why is it rational? Because it's 11 by 2. 5 plus 6 is 11. 11 by 2. P by Q, it's rational. So whether it lies between 5 and 6 or does not lie between 5 and 6, it is rational. It's not irrational. So leave it. Root of 5 plus 6. Root 11. What is root 11? 3 point something, right? Because 3 3s are 9. 4 4s are 16. 3 3s are 9. 4 4s are 16. So it will be 11 lies between 9 and 16. So it will be 3 point something. 3 point. It will be a non-terminating, non-repeating decimal. But it's 3 point. It's not between 5 and 6. So leave it. It's not that also. C. D is none of these. Check C. What is root of 5 into 6? Root 30. Now you don't have to exactly find the value of root 30. But where does it lie? 5 5s are 25. 6 6 are 36. 30 lies between 25 and 36. 30 lies between the perfect squares 25 and 36. 5 5s are 25. 6 6 are 36. So what will be the square root of 30? 5 point something. It won't be 6 point because 6 point means 6 6 are 36. More than 36 only will be 6 point. More than, only if the number is more than 36, it will be 6 point. Correct? Yeah, now this is 30. So it will be 5 point something. And it will be, because 30 is not a perfect square. If it's an imperfect square, the decimal expansion is non-terminating, non-repeating. All imperfect squares, imperfect cubes, a number which does not have a perfect fourth root, a number which does not have a perfect fifth root, all these are irrational numbers. If a number is not a perfect square, or if a number is not a perfect cube, then the square root of that number, the cube root of that number are all irrational. So 30, it's not a perfect square. So square root of 30 is an irrational number. So this is, and it lies between 5 and 6. So this one is the correct option. This one, because this is root 30 and it lies between 5 and 6. It lies between root 25 and root 36. Root 30 lies between root 25 and root 36. So you can write that. Let me write the justification for you. See, in the exam, you just have to select the option. But what is the reason? Write down this. Next one, a rational number between root 2 and root 3. A rational number, not irrational, between root 2 and root 3. So forget option A. Option A is irrational because root 2 plus root 3. Root 2 is irrational, root 3 is also irrational. So when the sum will also be irrational. So leave that. Root 3 minus root 2, irrational. So leave that. Then we have only 2.5 and because the first and second options are irrational. Square root of 2, square root of 3, these are all irrational. 2 is not a perfect square. 3 is not a perfect square. So square root of 2 and square root of 3 are irrational. So leave the irrational numbers. 2.5 and 1.5. Is 2.5 rational? Yeah, it's a terminating decimal. It is rational. Is 1.5 rational? Yeah, it's a terminating decimal. 1.5, that's it. It is rational. Now, which of this lies between 1.5? Yeah, because 1.5, because what is root 2? 1.414. Root 2 is equal to 1.414. And what about root 3? 732. 732. So you can see that 1.5 lies between 1.4 and 1.7. So the correct option is D. D is rational. First thing is 1.5 is rational and it lies between root 2 and root 3. Right on, children? Done, Netra and Tanishka?
Yes, ma'am.
Question number, children? 6. Yeah, try this, children. Done, Netra, Tanishka?
One minute, ma'am. Doing.
Yeah, Tanishka?
Doing this one.
Yeah. Tell me. Yes, class here. What's the product? Still doing? Okay. Oh, I'm so sorry. Oh, I didn't try. Sorry, children. I'm so sorry. This is cube root of 3. Cube root of 3 into, sorry, fourth root of 3. I made a blunder, sorry. It's cube root of 3 into fourth root of 3 into 12th root of 243. I'm so sorry. Cube root of 3 into fourth root of 3 into 12th root of 243. Sorry, children. Yeah. Please correct the question. Are you writing the questions, Raja? Question have you written down? I corrected the question now. We'll do together. Yeah, we'll do together, children. So let me first write what is given. Okay. So we have to find cube root of 3 into 4th root of 3 into 12th root of 243. So what we'll do is we'll write this in the exponential form so that we can use the rule when bases are same and its multiplication, we add the powers. So we'll write it in the exponential form. So this will be 3 to the power 1 by 3 into 3 to the power 1 by 4 into 243 to the power 1 by 12. Now tell me 243 in base 3. What is 243 in base 3? Is 3 to the power? Yes, I want the answer from Arjun. I want you to express 243 in base 3. 243 in base 3 quickly.
Ma'am, it's 3 power 5.
3 to the power 5. 3 to the power 5. You started working, Arjun? Okay, tell me, what have you worked? 243. 81. 27. Correct. 3 ones are. So how many threes we have? 5 threes. So 3 to the power 5. Okay, so 243 is 3 to the power 5. And there's already a power 1 by 12. What do? You multiply the powers. There's already that 1 by 12 there. So into 1 by 12. Multiply the powers. 243 is 3 to the power 5. But there's already the power 1 by 12. So 5, how many ever powers the base has? Multiply the powers. 5 into 1 by 12. So this is 3 to the power 1 by 3 into 3 to the power 1 by 4 into 3 to the power 5 by 12. Now use the law of indices or exponents. When bases are same and its multiplication, we add the powers. So 1 by 3 plus 1 by 4 plus 5 by 12. Okay, so take the LCM, 3 to the power, 12 is the common denominator, 4 plus 3 plus 5. So that is 3 to the power 12 by 12 or 3 to the power 1, which is 3. So the value is 3.
Completed, ma'am.
Very good. When bases are same and its multiplication, we add the powers. And when the base is raised to many powers, multiply the powers. So 3 to the power 5, but it's already raised to the power 1 by 12. Multiply the powers, 5 into 1 by 12, 5 by 12. Then take the LCM for the powers. We get 12 by 12, which is 1. So 3 power 1 is 3. So the value of the given expression or the product of the given expression is 3. Option B. Next one. every rational number is a real number. Is this correct? Every rational number is a real number. No. Yes. Every rational number is a real number. Every rational number is a real number. Huh? Every rational is real. Yeah, be sure about your answer. Yes. See. Real number is the total collection, right? Real numbers is the total collection. In that we have rational. So it's like zoo. The zoo is like real numbers. Real numbers is like the zoo. And there are giraffes in the zoo, right? So every giraffe is an animal? Yes. Every giraffe is an animal. Real number is the complete collection, right? Real number is a complete collection like the zoo. And in the zoo, we have different animals. Like that, in real numbers, we have rational numbers. Now, every animal, so every lion is an animal, right? So every rational number is a real number. Real number is a complete collection. Every rational number is a real number. But the other way is not true. Every real number is not a rational number. Every animal is not a giraffe. Every animal need not be a giraffe in the zoo. Every animal is not a giraffe, but every giraffe is an animal. Every rational number is a real number. Real number is a total collection. So every rational is real. But the other way, every real number is rational is false because real numbers also have irrational numbers, which is not rational. So this is not the option. So every rational number is a natural number. Every rational number, is it a natural number? No. See now 3 by 5 is a rational number, but it's not natural. Okay, then whole number. Then integer. So which is the correct option? Every rational number is a yeah. Correct. Every rational number is a real number is the correct option. 2 to the power -6. Okay, I don't have the answer actually. Let's see. Yes, online students don't have to wait for me to ask you to answer. Whenever you want, you can share your thoughts. Just feel like as if you're in the physical class.
Answer is 2 to the power -6, ma'am.
2 to the power
Yes, ma'am.
-6. Okay, let's see if I'm getting the same answer. So it is 4th root of cube root of square root of 2 square. All right, so first let me remove the 4th root, okay? So it will be like this, to the power 1/4, correct? So then what will be in this cube root of square root of 2 square, correct? Then let's remove the cube root. So it will be square root of 2 square, and then it will be 1/4 into 1/3. Multiply the powers. When you're getting many powers multiplied, so that's equal to 2 square. You can multiply this 1/12. Correct, children? No, see, when I'm writing, you should look at the screen. 2 to the power 1/12. Okay, then now tell me, Raja. Yeah, now. I've removed the square root. So it will be into 1/2. So this is, now you can see so many powers here. 2 to the power 2 into 1/12 into 1/2. So 2 and 2 gets cancelled. Correct? So 2 to the power 1/12 I'm getting. How you are all getting? Let me do it again. Tell me if I'm wrong. 1 minute, children. Let's do it together again. Let me write the expression. It's the 4th root of cube root of square root of 2 square. Correct? Now see what I'm doing. Raja, see the board. Yeah. So power 1/4. Now what will be here in the bracket? Cube root of square root of 2 square. Now remove the next one. 1/4, let it be there, into 1/3. So it will be square root of 2 square. Then in the next step, remove the square root. So it will be 2 square. And if you want, don't multiply it, have it as it is, into 1/2. Now multiply all the powers. 2 to the power 2 into 1/4 into 1/3 into 1/2. So 2 to the power 1/12, or no, that's why I asked why 2 to the power 1/12 is 2 to the power 1/12 only. It's if it was 1/2 to the power -1/12, then it will come up to the numerator as 2 to the power 1/12. 12th root of 2. Yeah, it's also the 12th root of 2. It's also the 12th root of 2. But what option is given? 2 to the power 1/12. So that's the correct option, children.
Yes, ma'am.
I think I mentioned this, maintain a separate book for revision. Did I say that in the last class? Have you got a new book? No? Yes, you? Oh. Sorry? Okay. No. Okay. All right. So maintain a new book, or you continue the same book. Okay. Continue the same book. If you have not got a new book, continue the same book. You can do that actually. Yeah, you can get a new book if you have time. Just write down in that book. That's only for revision. The 2 regular classes have that other book. But this Sunday's class alone maintain a different book. Arjun, is 2 to the power, sorry, is 1 by 2 power minus 1 by 12 a part of the answer? On the board, 1 by 2 to the power minus 1 by 12. Is that a part of the answer? No. And below that, 2 to the power 1 by 12. Is it a part of the answer? Yeah. That anyway, this was not a part of it's here. Question number 9. Huh? Is it 9? Yeah. True, false. True. It is rational. It is not rational. Netra, Tanishka?
Ma'am, it is not rational.
It is not rational. What if I say it is rational? It is rational. Okay, the correct answer is it is rational.
Ma'am, it is
All right.
false.
It's false. So that means it is rational, right?
Yes, ma'am.
Yes,
Because
ma'am.
Rational number.
Yes, Tanishka? Because
because rational number can be integer, whole number, and natural number, ma'am. It does not matter. We have to always have the integers, ma'am. So it can be of natural number or whole number, ma'am.
no, but integers includes that, no?
Ma'am, but
Integers
we
has Integers has natural numbers and whole numbers in them. No, that is not the reason. Now, Netra, P by Q, no. No, P by Q, okay, P by Q, but how? It is in the form P by Q. It's in the P by Q form, right? Root 18 by root 8. No, but P by Q form where P and Q are integers. Root 18 and root 8 are not integers. What's the definition of a rational number? A number that can be expressed in the P by Q form where P and Q are integers and Q not equal to 0. P and Q, are, if you look at that as P by Q, root 18 is not an integer. Root 8 is not an integer. Because you should always simplify before you comment. Before you comment, you must simplify. How do you simplify? Like this, you simplify, which is 3 by 2. And 3 by 2 is P by Q, integer by integer. It is rational. You must simplify and then give your comment. Root 18 by root 8 is root of 18 by 8. No. See, that also you cannot find completely, right? You cannot find the square root of 18 and 8 completely. Yeah. So square root of 18 by square root of 8 can be written as square root of 18 by 8. Now you can simplify. 2 9s are 2 4s are. So square root of 9 by 4. And what is the square root of 9? 3. 4, 2. So square root of 9 by 4 is 3 by 2. 3 is an integer. 2 is an integer. So 3 by 2 is P by Q, where 3 and 2 are integers. So it's a rational number, the given expression. Therefore, root 18 by root 8 is you must first simplify. On simplifying, you get 3 by 2, which is P by Q. Integer by integer. So it's a rational number. So that means the given statement is false. You should write that. The given statement is false. Right, next one. It's happening. Yeah. Netra and Tanishka? Tenth one. The answer for the 10th one. 10th one, children.
Ma'am, 509 by 4.
509 by 4 for the 10th one. Huh? Okay. Here, class 10. We'll do together. Okay, fine. Okay. So the question is, we are seeing the answer for the 10th one. The 10th one is the question. Yeah. What is 128? 2 to the power?
2 to the power 7, ma'am.
2 to the power 7. Do we know how to find it? Okay. So 128 like this, boys. 128, 264 times, 232 times. This we know how to do. Yeah, so like that. When you work that, you get 128 is equal to 2 to the power 7. Okay, let me write the question, I think. The given expression is this, the 10th one. The given expression is 128 to the power minus 2 by 7 minus 625 to the power minus 3, the whole power minus 1 by 4 plus 14 into 2401. The whole power minus 1 by 4 is the expression given, which has to be evaluated. 128 is 2 to the power 7. Correct? Now there's already a power, no, minus 2 by 7. What do you do with that? Into minus 2 by 7. So what will happen? The 7 and 7 will get cancelled. Then minus 625 is what? 5 to the power 4.
5 to the power 3.
625. 5 to the power 4, because 5, 125 times, 5, 25 times, 5 5s are, and 5 1s are. So it's 5 to the power 4. 5 to the power 4. But there are already 2 powers. So multiply them into minus 3 into minus 1 by 4. Plus 14 into, what is 2401? 2401?
7 to the power 4.
7 to the power 4. So 7 3s are 21, 3 remains, 7 4s are 28, 2 remains, 7 3s are 343, 7 49 times, 7 7s are. Very good. Who said this? Netra?
Yes, ma'am.
Very good. 2401 is 7 raised to the power 4. All right, 7 raised to the power 4. So here also 4 and 4 gets cancelled. So we have 2 to the power minus 2. Look at the board, minus 5 to the power what? Minus 3 into minus 1 plus 3.
Plus 3.
Plus, you can cancel the 4 like this itself. See here, this is the numerator, correct? 4 is 4 by 1 and this is 1 by 4. So you can cancel the 4s. 14 into what? 7 to the power?
1 minus 1.
Correct? Okay, so what is this? What is 2 to the power minus 2? 1 by 2 square. 8th standard. Reciprocal of the base, negative of the power. Reciprocal of the base, 2 becomes 1 by 2. Negative of the power, minus 2 becomes plus 2. 2 is 2 by 1. Reciprocal of the base, 1 by 2. Negative of the power, minus 2 becomes plus 2. So 2 to the power minus 2 is 1 by 2 square. Minus 5 cubed as it is, plus 14 into 1 by 7. Because 7 by 1 is 1 by 7. 7 by 1. Reciprocal is 1 by 7. Reciprocal of the base, negative of the power. Minus 1 becomes plus 1. So 1 you don't have to write. 7 power 1. So now again you can cancel this. 7 1s are 7 2s are. 1 by 4 minus 125 plus 2. So this is 1 by 4 minus 123. Now you'll have to take the LCM. You'll have to take the LCM. What's the LCM? 4 is LCM. So it'll be 1 minus 2, 1 carry over. I don't know how to multiply. 9, 2. of 4. Correct? So minus 491 by 4. Just check my simplification alone. 490. Is this right? I think Netra had a different answer.
Yes, ma'am.
Where have you gone wrong?
Ma'am, I have changed the minus symbol to plus symbol by mistake, ma'am.
Okay. Understood, children? See the next one, the value of, this is over. Netra, Tanishka, 10th one is over. Okay. The 11th one. So base are same and it's multiplication. So we'll have to add the powers, right? So it will be 144 to the power 0.4 plus 0.1, correct? First step, add the powers. Second step, 144 to the power 0.5, correct? Now, Arjun, what is 0.5 as a fraction? Quick. 0.5 as a fraction. 5 by 10. That simplifies to 1 by 2. So 144 to the power 5 by 10. So that is 144 to the power 1 by 2. Correct? That means what? What is 144? 12 square into 1 by 2. So 2 and 2 will get cancelled. 12 is the answer. 144 is 12 square. 12 into 12. Yeah, right on, children.
Completed.
study, and we had school only from 9:45 to 3:30 or 3:45. So we had time to study in the morning as well as in the evening. Morning easily, see, 6:30 easily we could wake up, because those days no television and all that, so hardly children stayed up late in the night. Now we have different things to entertain ourselves. Social media is distracting. You have reasons to stay awake today. Nowadays we didn't have any reason to stay awake. There was nothing on the television, no gadgets, nothing. So we had to sleep early. So we got up early, and we had time to study in the morning. It was very relaxed. And there was no pre-board exam, nothing. I didn't even know the model paper for the board exam. Nothing, no stress, absolutely. It was just another exam, that's all. There was no stress whatsoever for the board exam. No extra classes, nothing. But the teachers were so good. They completed the portions well in hand. They gave us good revision. They supported us well, both mentally and physically. And we never felt we were writing the board exam. They took us through the exam so easily. Simply 9:45 to 3:45, 6 hours of school. So 3:45, 4:30 we used to come home. We used to play with the children in the neighborhood. And when it gets dark, go home, do the homework, whatever. School itself was good enough, we used to understand in school. We never needed extra classes. We've never attended tuitions. Those teachers are so good. Why tuition when the teacher is so good at school? Now, that it's nothing. The board exam is nothing, but they're making it like a mountain. It's just a mole, but it all is, magnified in so much of time at school. So like 7:10, you leave and come home at 6:30. Even people who work leave home little late. That also is too much, no? It's too much. So you have 2 breaks to eat. 5 breaks. Why 5 breaks? Give us 1 break and reduce the duration in school. All right, I think we have to see the answer for the. Oh, it's over, is it? 10:11 we finished. Okay. Yeah, this understood. Bases are same. It's multiplication, so we'll have to add the powers. 0.5 and then convert that to a fraction, 5/10, which simplifies to 1/2. And 144 is 12 square into 1/2. Understand? Or you can also write 144 to the power 1/2 as square root of 144, which is 12. 1/2 power is 1/2, meaning square root. Good evening, Siram. Yeah,
Ma'am, the first one is rational.
the first one is rational. How do you simplify that?
Ma'am, a square minus b square, ma'am.
Correct. A plus b into a minus b is a square minus b square. So the first one is 3 the whole square. The answer for the 12th one, the answer for the 12th one, 3 minus root 7 into 3 plus root 7 is of the form a minus b into a plus b, which is a square minus b square. So it's 9 minus 7, 2. And 2 is rational. The question is it irrational? No. 2 is 2 by 1 is rational. Is rational. Correct? The next
Yes.
one? Yeah. Root of 3.61. Yeah, what is this? Slide the. Yes, children. Root of 3.61.
Root
So
of
write it
1 by 100.
361 by 100. And what's the square root of 361? 19 19 into 19. Multiply, you get 361. So it's 19 by 10, which is 1.9. 1.9. Or you can just leave this 19 by 10. Or because the question is a decimal, you can leave this 1.9. What is this? It is rational because it's a terminating decimal. It is rational. Yeah, next one. The 14th one. What's the value? So open the bracket, it will be, good evening, Siram. Root 2 plus 3 minus root 2 plus 5, correct? So this cancels 5 plus 3, 8. Last one. Remember we did root 18 by root 8. Root 18 by root 8. In the same way, root of 12 by 75. Root of 12 by 75. Simplify using the tables of 3. 3 4s are 325 times. So what is the value? 2 by 5. 2 by 5 is P by Q. Rational. Root 12 by root 75 is root of 12 by 75. Simplify using the tables of 3. 4 by 25. 2 by 5. Which is rational. P by Q form, so rational. Netra and Tanishka, if you finish writing, you may leave the meeting. Yeah, that's it for today's class. Thank you.
Thank you.
Yeah, thank you.